All right, so acid nomenclature. There's 3 rules for naming acids. The first one is binary acids. So this would be like basically an H and one other element. Oh no, what are you doing? Element. You're messing up my video. All right, one other element. So 2 atoms. Whenever you have something like that, which there's an example right here, HCl, HBr, okay? You use the same format for naming them, okay? It's always hydro and then the stem of whatever the element is that you're using, and then ic at the end of it, all right? So for example, this would be hydrochloric acid. All right? So what would the next one be? Yep. Hydrobromic acid. All right?
So it's one word together?
Yep. How about this one? H3P. Ryan? Yep. Hydro phosphoric acid. Notice it's not hydrophosphic acid, right? It's phosphoric. They do that with 2 elements to make it sound better: sulfur and phosphorus. Those are the main 2 we'll see this year. All right. What about this one? Hydronitric, right? Notice it's not hydronitrogenic, right? It's just hydronitric acid. All right, cool, everybody's good with that? All right, that's the first rule. The second rule and the third rule deal with polyatomic ions, all right? So a oxyacid is an acid with oxygen. They're your polyatomic ions as acids. So you just take whatever polyatomic ion you're dealing with, and then you add however many H pluses you need to neutralize it. So we're back to dealing with ions, right? Because they're the polyatomic ions. So CO3 minus 2, how many hydrogens do you need to balance that out? Yeah, 2. So it would be H2CO3. Not bad, right? Because each hydrogen is just plus 1. All right, everybody's good? Okay. So now things get a little crazier when you have to name them. So if the polyatomic ion ends in ATE, you're going to change it to IC. Okay? So ATE changes to IC. What's the name of this polyatomic ion right here? What's CO3? Good. Carbon 8. So what's that ATE going to change to? Right, it's going to change to ic. So it's going to be carbonic acid. All right, carbonic. Yeah. Notice that there's no hydro at the beginning, right? And that's going to be a common mistake, is putting hydro where you shouldn't. Hydro is only if it's 2 atoms, right? Notice the one we just dealt with had 3 atoms in it, right? So you never use hydro unless there's only 2 elements, all right? Okay, so we have this carbonic acid here. The second change, the second thing to remember is if the ending is ITE, it changes to OUS. All right, so OUS. So let's talk about NO2 minus real quick. How many H pluses would you need for this to balance it out? Just 1, right? It's minus 1. So you need 1 plus. All right, so that's what the formula is going to look like. What's the word going to be? All right, first of all, what's NO2? Good. So that's nitrite. And then, yeah, as you say, it's ITE changes to OUS. All right? So this would be nitrous. Nitrous acid. All right? Good? That's kind of it. If you've ever seen the movie 300, it's like the Sparta movie, right? The main character's name is Leonidas, which sounds like Leonite to us. Get it? Right? So there, you'll never forget it. All right? Ite to us, Leonidas. Perfect. Okay, is everybody cool with that? It's the end of the show. End of the show.